Hey guys, welcome back. We're continuing with the Trigonometry 2020 Test, Calc section. Same deal, stream of consciousness, running through each question as I'm thinking through them, pointing out any common mistakes if I can think of them at the time, and I guess I'm talking about the concepts as I'm going through them. Alright, so 6a. Find the value of x in each of the following drawings. Part A, we've got a diagram, we've got two sides and the included angle. X is opposite the included angle, or opposite that angle. That could be useful information. Okay. Let's just talk about part A for now. We'll go through part B next. Part A, we have a triangle, two sides and the included angle, and we're trying to find the opposite angle, opposite side. Okay. Two sides and the angle in between, to me, sounds like the cosine rule. Okay, this is different to the sine rule where you're looking for opposite sides and opposite angles. Okay, this one we have the included angle. All right, included angle, cosine rule. Or a little bit later we might talk about three sides and you're trying to find an angle. That's the inverse of the cosine rule, and we'll get there. Cosine rule, we are looking at a squared is equal to b squared at c squared, and you might see it differently. Take 2bc cos of a. Doesn't matter what's a, b, and c, but a and the side, the angle and the side that we're trying to find have to be opposite one another. So this would be a, this would be little a. Doesn't matter whether this is b or c, really. So let's fill this in. X squared is equal to b 9.8 squared add 11.2 squared, take 2 times 9.8 times 11.2 times cos of, and I'm running off the page a little bit, 105. Alright, so x squared is equal to, now we're in the calc section. Let me clear the history from my last video. So I've got 9.8 squared plus 11.2. Tap across when you're doing powers, 11 plus 11.2 squared. 2 times 9.8 times 11.2 times cos of, and make sure I'm still in degrees because I'm using degrees. Sure am. Cos of 105. Alright, and so x squared is equal to negative, 278.26, not negative. So we need to take the square root. That is not what x is equal to. This is what x squared is equal to, and we can square root, and you can either use your directional pad and press enter to grab it, or you can use control negative here to use the answer. It's up to you. Okay. If you're going back more than one answer, it might be useful to scroll through, chuck it in. So x is equal to 16.68. Just going to two decimal places for now. It doesn't actually say in the question. It's not super important, but what is that I don't round this answer that I've got for the first part until I'm actually giving my final answer. So I'm happy to give, oops, cancel that. Happy to give this as a part of my solution, but I can't. I've got to make sure I continue to use the full value of my calculator, not say 278.3 if I was rounding that one. only round at the final answer. Okay. Part B, we are looking at a triangle, and it appears that it's got opposite sides and opposite angles. Okay. Usually I see some sort of X here in my mind, or I just draw it in. This to me is a sine rule situation. Okay. Now the thing that we're trying to find is the angle, so we want to have sines up top. Sine of x is equal to over 17.3 is equal to sine of 27 over 16.2. Got to be consistent about where your sines are. Sine can't be on the top on one side and bottom on the other when you first write it out and you're substituting. So now that we've got that, we can say sine of x is equal to 17.3 sine of 27 over 16.2. So just times both sides by 17.3 and got rid of the denominator or the fraction there. Alright, which means that x is equal to sine to the -1 of 17.3 sine of 27 over 16.2. Alright. And we'll talk a little bit more about the inverse of sine here because it changes one of my answers a little bit. Alright, so we've got sine to the -1, double check, still in degrees. Cool, I want degrees as my answer. So trig sine to the -1 of fraction 17.3 sine of times. Sometimes not putting that times in there can mess up your answer. Okay, or it might give you some sort of error. Sine of -1 of this is equal to, I think we can safely say just 29 degrees because going to 4 decimal places seems a little unreasonable. But anytime we are doing the inverse of sine, like we have here, okay, there are two solutions, and that goes to the idea of a unit circle. Okay, so between 0 and 180 degrees, okay, there are two values, two angles that have the same height. Okay, let's say one is 29 like in our example here, then the opposite side here has to also be 29, the angle made with the x-axis, which means the angle from the positive is 180 take 29. Okay, that is another solution for sine to get the same value as whatever this giant thing is. Alright, so 180 take 29 is my other answer. I have to consider it if I'm doing the inverse of sine. It doesn't always work, which I'll demonstrate and see. Okay, 151, if I was to put 151 here, 27 and 151 still is less than 180, so it's a valid solution. It could still work. It'd be a weird looking triangle, but it's possible, so you need to include it. Alright, let's try part C. So we have two triangles here. Right, we are doing trig, so we're thinking of triangles. One is 90 degree, the other one is not. Okay, so my SOHCAHTOA rules apply for this lower triangle. they do not here. And what I'm trying to find is this angle. So what I'm thinking is, well, this angle and this side pairs up pretty well. Okay, so this is looking more like a sine rule thing, but I need to pair up this 100 degrees with whatever this side is. So can I find that side? The other tricky bit here is that this is in centimeters and this is in meters. So we want to make sure that when I get to it, I am using the same units, and let's just assume that I'm using meters. Okay, you could convert this to centimeters and do it that way. It's up to you. Okay, still should get the same answer, but units need to be consistent. So let's go back. If I can find out this side, then I can use my sine rule to find x. So I have a 90-degree angle triangle here with a side angle and a side, so I should be able to find y using SOHCAHTOA. I need to use adjacent and hypotenuse, so I'm using cos, CIH, adjacent, hypotenuse. Cos of 29 is equal to adjacent over hypotenuse, so y is equal to 1.2 cos of 29. Alright, I can work this out right now, but gotta be careful with rounding. Alright, so I can say that this is equal to 1.37 now, but when I use that value in my next calculation, then I want to make sure that I am carrying the rest of it. So, sine rule, I am trying to find x, sine of x on 0.85. If you do not use that 0.85, in fact I might demonstrate it, then you're going to get a math error. Okay, we'll come back to it. Sine of x is equal to 0.85, and that's equal to sine of 100 over my 1.37 or y or whatever you want to put in there. But remember, I'm not using 1.37, I'm using the value in my calculator, which is a little bit more than 1.37. So I'm going to skip a step here. Still 100 in that bracket there. Okay, so I'm going to be doing sine negative 1 of 0.85 times by sine of 100 divided by not 1.37, but this value here, no, it's not going to do it the way I wanted to. I'm going to use, okay, if I want to, I could go up here, Control C, will copy, and then I can paste in there. That will work for now. Control C is copy, Control V is paste in on your calculator, just like it is on a computer. It's kind of handy. Control Z also undoes. It's pretty useful. So we have x is equal to 37.6. I'll just go to one decimal place for now. Now, what if I hadn't been consistent about the units and that was actually 85 instead of 0.85 centimeters? Undefined error, okay? This is because everything that is inside the bracket here is much greater than 1. And what do we know from our unit circle and sine? It's that sine has to have a maximum of 1 or a minimum of -1. Okay, just comes from the unit circle. So if you're trying to do the inverse of a value that isn't between 1 and -1, okay, sine is your height, then you're going to get a math error because it doesn't exist. Okay, so like before, because we've done the inverse of sine, we want to make sure we consider the obtuse case. So I'm going to do 180, take my value from before, okay, 142.4. But if I was to put 142 into here, 142 plus 100, very much bigger than 180. That's not going to work for that angle. So it's just 37.6 is the solution that I want. Alright, well that's question 6. Let's move on to question 7. And we have some bearings in this, so a ruler might help. Okay, we have 2 compass style bearings rather than true bearings in this thing. Means I am starting from the first value, turning towards the second bearing, or compass bearing here, compass direction, cardinal direction would be the one. First cardinal direction starts south, okay? And then I'm going to turn towards east 25 degrees. This would mean that I'm starting at north and I'm turning 40 degrees towards east. So let's see if we can do this. I'm going to write north and south here for now. Alright, and my first bearing, this is at my port, and it sails on a bearing of south 25 degrees east, so I want a 25 degree angle here that I've created towards east. East is on this side, so I'm 25 degrees in here. Okay, and then I am traveling for 300 kilometers, for 300k. And anytime I make a stop when I'm doing my bearings, marking north, it is a useful thing to do. And then my next bearing, so I turn this ship around a little bit and I am going in a bearing that is starting at north, but it is 40 degrees east. Okay. It works something like this. Okay. It doesn't have to be perfect with your scale. And then I've stopped again. So if I stopped, chuck in a north. Okay. The reason we're chucking in north, or north and south, is that your parallel line rules very much apply. So you've got 3 parallel line rules that we should be very familiar with. Okay, let me just go through them once. Alright, you have the Z rule, parallel lines here, theta, and let's just use beta. Theta is equal to beta. We have parallel line rules here, and we've got what looks like an F, this looks like a Z, this looks like an F, okay? Alpha and beta this time, alpha is equal to beta, and then you have your third parallel line rule, okay? I'm going to do it a different direction to what I normally do. Alright. Maybe I should have done it more on a slant. Regardless, alpha and beta, the 2 angles that are co-interior, co-inside, are supplementary in that they add up to 180 degrees. All of those rules are useful when doing angles of elevation and depression, or when doing your bearings. Okay, because north-south is parallel to north-south, so I hadn't added in my 40 degrees here or my 120 kilometers. There's my diagram, okay? What I'm actually trying to find might be a good part. How far is the boat from the port? Give your answer to the nearest kilometer. So if this is the port and this is the boat, okay, I want to find this distance. Okay, now I have two sides. I have this side and this side. Okay, I know both of those, and if I can find the whole angle here, the angle in between them, or the included angle, then it's looking a lot like cosine would be useful to me. Okay, I don't really know many other angles here, so sine rule is less likely, but let's see how it works out. Can I find this entire angle? Well, I know part of it is 40, okay, and because north-south is parallel to north-south here, I have, and you might not be able to see it that way, might be easier that way, you have a Z. Okay, this angle in here is equal to this angle in here, 25 degrees. So the total thing is 65 degrees, which means that x squared is equal to 300 squared plus 120 squared. Take 2 lots of 300 times 120 times cos of 65, which is that entire angle in here, 65, 40 plus 25. And I am most of my way to finding x. Okay. So I am doing 300 squared plus 120 squared. Take 2 times 300 times 120 times cos of 65. Again, still in degrees. Alright. And then I wanted to put it on here. Want to take the square root of that. I'm not so worried that this is not a thing. I can click up and highlight the whole thing. Enter. Now I do want it as a decimal. Okay. So x is equal to 271.9798, but we want it to the nearest kilometer. Give your answer the nearest kilometer. So x would actually be 272 kilometers. Alright, a little bit lazy with that rewriting, but show all you're working out if you're doing a test. Okay, don't shorthand it like I have here, it's just for the sake of the video. Alright. Question 8. A mast perpendicular to the ground, which is why it's got this 90 degrees here. Alright, this part is the mast. It's held up by two wires, one on either side. Each wire is anchored on the ground. Assume the ground is level. Cool, good to know. So one wire isn't higher up or lower down than the other. And at the top of the mast, so here's the top of the mast. Both wires are connected to there. If one wire is 11.2 meters and the other is 6.7 meters, and at ground level they are 14.2 meters apart, how high is the mast? So that's what we're trying to find. We have a 90-degree angle triangle. Can we use it in some way? Probably, okay? If we knew one of these other two angles, or possibly this angle in here, then we could use that 90-degree angle on that 90-degree triangle. So can we find one of these angles? I'm going to stick with this one in the corner, and I'm going to call that alpha. Can I find alpha? Well, I can. The cosine rule connects three sides at an angle. I know three sides, which means I should be able to find the angle. Or, cosine rule, if you know two sides and the included angle, then you can find the other side. This is three sides at an angle. We need to make sure that the angle that I am trying to find let's start with the formula itself. Let's say cos of A would be b squared add c squared, take a squared, again you might see this slightly different, divided by 2bc. The side that I am taking, A, has to be opposite the angle that I'm trying to find. So cos of alpha is equal to 11.2 squared add 14.2 squared, take 6.7 squared. 6.7 is opposite alpha, so that's why I'm taking 6.7. Very important part of the problem, because if you took a different number, you're finding a different angle. And that could be useful if you found this angle or this angle, but if you're not understanding it correctly, you're more likely to make mistakes later on. Okay, so I am doing start a fraction here, 11.2 squared plus 14.2 squared, take 6.7 squared, and then 2 times 11.2 times 14.2. Okay, it is a number less than 1, which is great for us because we're trying to do the inverse of cos, which has to be between -1 and 1. You can see that on a cos graph if you wanted to. So cos alpha is equal to cos to the -1 of 0.887. Alpha is equal to, just be writing that on the page. So we want to go cos to the -1 of all this, 27.48 degrees, because my calculator is still in degrees. So I know that this is 27.48 degrees. What I still don't know is the mass, okay? And I've left myself very little room to do it again, so I'm going to do it in this little corner here. I have a 90-degree angle triangle. I know that this angle is 27.48, and I know that the hypotenuse is 11.2, and I'm trying to find this, so I'm using opposite and hypotenuse. Sine of 27.48 is equal to opposite x over the hypotenuse, so x is equal to 11.2 sine of 27.48. Okay, I've just times both sides by 11.2, which means it comes out the front. So x is equal to, don't use 27.48, you want to use, all of this, okay, 11.2 times sine of 5.17 meters. You could probably do it to 1 decimal place because every other number in here is given to 1 decimal place. So let's try that again. All my other values are given to 1 decimal place, so I will do that for my answer too. 5.17 becomes, well, 5.16 becomes 5.2. Alright. Question 9. Use your calculator to solve this large trig function between pi and 3 pi. Alright, well, if we're doing this because we are working in radians, the first thing I want to make sure that I do is change my settings to radians. Make sure you know how to do that for yourself because that's an important part of the process. I'm going to clear what I've done before. Cool. And what I'm trying to do is solve this whole thing algebraically. Okay, so I'm going to use, well, not algebraically, I'm trying to do it on my calculator. I'm going to use the algebra section on my CAS, on my TI here, and I'm going to solve menu 3, 1. Okay, so I open up the solve and I'm going to type exactly what I see here for my equation. I'm giving the calculator the equation that I'm trying to solve. So 3 take 2 times, make sure you put in the times because if you don't write that in there it's going to give you an error, times cos of 3x plus pi on 3, and this is equal to 1. Now before I get out of this solve set of brackets, so you'll see that there's brackets at the beginning and the end of the solve part, I do need to tell the calculator what part of my equation I'm trying to solve for. Okay, in this case I'm trying to find out what x is. You can use a different letter if you like, but I definitely need that comma x in here. Alright, normally this would be a-okay for most algebra problems, but trig equations have that periodic, repeated nature, and so there's infinite many, and your calculator will try and give you all of them, unless you tell it where to look, which is what we're going to use here. We're going to use this straight line up here, 4, okay, and then I'm going to say that I'm going to give it my domain, x, pi, less than or equal, so you find all of these symbols in the equals part of your calculator of your TI. Casio ClassPad's a bit different. I won't show that here, but feel free to ask me. And then x, 3 pi. Okay, so straight line up means that for these values of, or between these values of x, I'm trying to solve this function. It gives me a much different answer. So x is equal to 11 pi on 9, 17 pi on 9, and 23 pi on 9. If you do not have your settings of your calculator, okay, if you're in your document settings, this is where you might be changing from degrees and radians. But what I want to talk about is the calculation mode here. If you do not have it on auto, maybe you have it on approximate, then it's going to give all the decimals. If you want the fractions, if you want the irrational numbers, the square roots, the pi's, etc., then keep it on auto. Okay, you can always change it to a decimal by using that control equals, and it'll give me the decimals instead. Alright, pretty straightforward question really. We just need to learn a bit more about how to use a calculator and then make sure that we are working within the correct units. Alright. Use angle and sum difference formulas to find an exact solution for sine of 75. Now we're in the calc section, so you should be able to find some solution for sine of 75 in an exact way, but this has told us to use the angle, sum, and difference formulas. Okay, you might need to be refreshed on them. This is what they look like on your formula sheet or on the scales of formula sheet. Sine is equal to, this has plus minus, so if you have a plus here, you have a plus here. If you have a minus here, you have a minus here. But you'll see that this one's actually the other way around. So this means that when this is a plus, this is a minus. When that's a minus, this is a plus. When it's upside down, it's the opposite to the other symbol. Okay, that's what they look like for sine and cos. The scales formula sheet does not have it for tan, okay, but it does occasionally come up. You can either commit it to memory or have it on your sheet of notes and hope it comes up in the calc section and not the non-calc section. Anyways, in order to use the angle, sum, and difference formulas, I need two angles that add together or subtract together to get 75. All right. Preferably, because I'm looking for an exact solution, numbers that go with 0, 30, 45, 60, and 90, because those are the exact values that we do or should know. All right. So sine of 75 is 30 and 45 go together pretty well to become 75, so that's what I'm going to use. Now I've got, this is A, this is B, you've got to apply this to the pattern in your formula here. So sine of 30 cos of 45, add cos of 30 sine of 45. Okay, trying to keep that part separate for now. So sine of 30 is half. Cos of 45 is 1 on root 2. Okay. Plus cos of 30 is root 3 on 2. Yep. And then sine of 45 is 1 on root 2. And these fractions are being multiplied together. Alright. So I have 1 on 2 root 2 plus root 3 on 2 root 2, or 1 plus root 3 on 2 root 2. That might be good enough, but because we have a denominator that has a third, okay, we might like to fix that up by trying to rationalize that third by multiplying by it on both the top and the bottom, okay? Timesing a fraction by the same thing on the top and bottom means it's still an equivalent fraction, so we're not changing the value of it, we're just changing how it looks. Okay, root 2 on root 2 is just 1, so we haven't done anything to it. Anyways, so we should get root 2 plus root 6 on 4. Okay, that root 2 is multiplying both the top and the bottom here. Oh, sorry, both terms on the top. Okay, root 3 times by root 2. Okay, can be brought under the same square root, so it's root 3 times 2, or root 6. Alright, that should be it. Okay, and if you are unsure, you could go into here. Currently I'm in radians, I want to change back to degrees. Sine of 35. Okay, they've brought the root 2 out as a common factor in this step here. They've just done bracket outside there and then made it a root 4. That also works. Okay, same value at the very least. Okay, tan of pi on 3 plus pi on 4 works a little bit differently. Okay, tan formula is not on your formula sheet, so you need to try and remember it. Okay, they are 1 opposite signs to top and the bottom, add same sign on top, tans are multiplied on the bottom. Okay, and add it together on top. Okay, see if you can recognize some patterns in your angle of sum formulas. Recognizing those patterns are going to help you to memorize it. Anyways, so we're looking at tan pi on 3 and pi on 4. Okay, we might need to go back to our triangles. 45 degrees is pi on 4. So tan of pi on 4 is 1. Opposite over adjacent. In this case, tan of, go back to it, pi on 3 is 60 degrees. Alright, so pi on 3 we're doing opposite over adjacent. Tan of pi on 3 is root 3. So you might prefer to have that on the side or on your sheet of notes. So we've got root 3 plus 1 on 1 take root 3. Okay. Simplifying that denominator is a little bit trickier because it is not something that we have gone over much or at all. To get rid of a situation where you've got 1 take a third or a number take a third, you need to multiply by what we call the conjugate, which is the same thing, but it's the opposite sign in the middle. Okay. And this works just like our difference of two squares. You square the first term and then you take the square of the second term. Okay, because remember that a plus b, not squared, times by a take b gives you a squared take b squared. Same pattern. A take b times by a plus b. Anyways, and the top part works like our perfect square. A plus b squared is equal to a plus a squared plus 2ab plus b squared. So this quadratic stuff, surprisingly, is coming up in your trigonometry stuff a little bit down the track. So we've got on the top line 1 squared plus 2 root 3 plus 3 squared, which is root 3 squared, which is just 3. 1 squared take root 3 squared is 3. Maybe it'd be easier if I chucked this idea in to some brackets. Okay, when you square a square root, then you get rid of the square root. 1 plus 2 root 3 plus 3. So do it in separate steps to make sure we're not missing anything. So we've got negative, because 1 take 3 is negative 2. 1 plus 3 makes 4 plus 2 root 3 on 2. 2 can divide both terms, top and bottom. Okay, so I can cancel 1 here, 2 here, 1 here. So we get negative 2 plus root 3. Negative 2 plus root 3, or negative 2 take root 3. Okay, that negative applies to the whole fraction, so all of the top line. Let's double check it on here. I am now in radians. 10 of pi on 3 plus pi on 4, close bracket. Same situation here. Negative root 3, negative 2. Okay, if you were to expand that bracket negative onto both of them, or what we had here. Cool. So that's definitely correct. Again, because it is the calc section, you could get some marks by taking this and jumping straight to here. Or if you knew this part, expanding this and then taking that and again jumping here. The work in between is a lot to do for 1 mark, honestly, but that's what it is at the moment. So 11. The circle shown below with center O has radius 3 pi. Okay, and the minor arc, the minor being the smaller arc, has a length of pi squared. So that arc, the round part, but in between A and B, the smaller one, because it is the minor, is pi squared. Show, so we need to prove that the minor angle AOB, but we're talking about the minor, so the smaller one here, is pi on 3. Well, we know the arc length and we know the radius, and we know that the arc length is the number of radians times by your radius. Okay, that is on your formula sheet for an arc, but it tells you that for an arc subtangent angle pi radian, not pi theta radians. So arc length is pi squared, r is 3 pi, and we're trying to find my angle AOB here. Divide both sides by 3 pi. Pi squared on 3 pi is theta. Pi squared divided by pi, the square will cancel with that, and I get pi on 3. Okay. So determine the length of the major arc. Alright, if we're doing the major arc, let's just go back to our diagram for a second. Major arc is going to be the larger arc around here. In order to find the length of that, we need to know this angle. Or you need to understand a little bit about this. If that's pi on 3, then the rest, the full circle is 2 pi on 3. So 2 take pi on 3, or 2 pi take pi on 3 is 5 pi on 3, which is what this angle is in here. Okay? It is 5 times bigger than this angle, so the arc length would also be 5 times bigger. So what we're looking for is 5 times pi squared, but we'll double check with our formula. My arc length L is R 5 times pi on 3 times by my radius. So what I've done is theta R instead of R theta. Doesn't matter because I'm timesing. So I'm multiplying, it just, order doesn't matter. So I have 15, the times by 3 and divide by 3 cancel each other out. So I would in fact get 5 pi squared is equal to my arc length. Alright, of the major one, the bigger arc. Alright, area of the minor segment shaded formed by the chord AB. So this shaded little part is what we call the minor segment. There is a formula to find the area of this. Here it is, area of segments. Area is equal to half r squared. Theta takes sine of theta. Area is equal to half r squared. Theta take sine of theta. Now the common mistake here was when people substituted their r in, they only squared pi. You need to multiply or square all of r here. Minor segment, so my minor angle is pi on 3, takes sine of pi on 3. Alright, now that we've got everything substituted in, I can go to my calculator times 3. Yeah, I'm in radians. I gotta check that I'm in radians because I'm using a trig function. If I'm using radians, then that trig function, if I'm using a trig function, that angle and the calculator has to be set to radians. Or rather, if I'm using radians in my trig function, then the calculator needs to be set to radians. Times by 3 pi all squared, so 9 pi squared if you are expanding that yourself, pi on 3, take sine of pi on 3. I'm missing a bracket somewhere. Oh no, I didn't want to times in there, that's better. Cool. So my area is 8 point, let's just say, everything else is in pi. Let's just say it's 8.05 centimeters, like that. Okay, you could plausibly do this because you know what sine of pi on 3 is as a exact value. You could do this as an exact value, but I don't think that's necessary here. Okay, and I probably should have put my units on this. 5 pi squared centimeters, and I think that's the only one that I was missing. Alright, don't forget your units, they are important. Anyways, that's it for this one. We're at the end of the test. Let me know if you've got any questions, and I hope that's helped.